Hello and welcome. This is a quick lesson on linear combinations taught by City of Heroes. Enjoy. Hello class, today you'll be learning about the wonderful world of linear combinations. Comrade Stalin says I have to learn math to be a better diplomat. I appreciate your eagerness to learn, but first you have to start with learning to count. You teach me this or I hit you with my mace.
I'm scared of maces.
I'll protect you because I'm a superhero. Class, calm down. We're just here to learn. Look, it's really quite simple. Let me show you. First, we start out with a problem. Well, two problems, really. See, these both have variables in the same spots. Your job is to get rid of one variable.
Eek! You mean like kill it? I don't like violence.
Don't worry. I'll hit it with my mace if it ever comes by. Quiet! First you see if either both of the x's or both of the y's in the problems have the same absolute value. Math is boring. Continue. Okay. Then whichever variable you chose, you check if they're a same number, positive or negative. If they are, you subtract the x variables, the y variables, and the sums from each other. If one is positive and one is negative, add them together.
Wouldn't that leave us with only one variable?
Very good. So what we're left with here is 5x equals negative 5. Good. We solve for x, so negative 5 divided by 5 is negative 1, so x equals negative 1. Then we simply plug in the x value into any of the two problems. So, 2 times negative 1 minus 3y equals negative 8. Who can tell me what we do next? I can hit it with my mace. I can. We asked someone else to do it for us. Nobody can hit as well as I can.
You're both wrong. We make it into negative 2 minus 3y equals negative 8, then subtract negative 2 from both sides. So negative 3y equals negative 6. Then solve, so y equals 2.
At least she knows what I'm talking about. Now here's what happens when the variables are not the same. You have to make them the same. So you multiply every number in one problem or both problems by the same amount. But the amounts can be different from problem to problem. So that either x or y in both problems have the same absolute value. Can we skip to the fun part? This is the fun part. Where's the alcohol then? Anyway, say we want to make the y's the same. In order to make them the same, we find least common multiple of 3 and 4, which is 12. And in order to get 12y, we multiply in our first problem by 4. So, 12x plus 12y equals 48. The other problem we multiply by 3. So, 15x minus 12y equals 138.
We add both?
No, I want to answer this one. The answer is 2. What? It's x equals 2 and y equals 2.
Oh, be quiet. We add the problems together to get 31x equals 186, which equals,
2, of course. X equals 6. Then you plug it in, so 4 times 6 plus 3y equals 12. So, 24 plus 3y equals 12. And 3y equals negative 12. So finally, y equals negative 4. So the final answer is y equals negative 4 and x equals 6. Class dismissed before you give me a nervous breakdown. Is that like hitting something with a mace? Bah, that was boring. I'm going to go save the day or something.
Eek! He has a mace!
It's my humble tool of diplomacy.